Hello everyone and welcome to Dr. Rajesh Biogenesis. In this session, I will just explain the plane of symmetry with respect to three molecules. All these three are simple molecules, and if you can understand how do we operate a plane, you can apply the same for even a complex molecule. The simplest of the molecules, we start with a water molecule, then I am choosing a BCl3 which is also a planar molecule. Third one is an ethylene which is also a planar molecule. But qualitatively there is some difference. To identify the planes that are present in a given molecule, one must have an idea about the rotational axis. In one of the videos you can find what is called as a vertical plane, horizontal plane and a dihedral plane. I made a separate video for it, you can just go through to understand these examples. Let me begin with a water molecule and let us try to identify the rotational axis present in it. There is only one rotational axis which is passing through oxygen. You do not have more than one rotational axis, and that one particular rotational axis we call it as a principal axis, and that is a C2. So there is a C2 present in the water molecule. When it comes to BCl3, BCl3 has two rotational axes. One is called as a principal axis with a C3, and the another one are C2s perpendicular to C3. Altogether there are three C2s in it. When then we come to ethylene, in ethylene also there is more than one rotational axis, but all of them have the same order. The one which is passing from more number of atoms is the principal axis, the remaining two that are perpendicular to it, they are considered to be the subsidiary or the auxiliary axis. Now let me draw the planes and try to show how the atoms get exchanged. In the first case, I am beginning with a water molecule, oxygen and two hydrogens. Let me try to pass a plane from the center, which is the oxygen. Now if I try to pass this plane, you can just check the hydrogen which is towards your right hand side, that will exchange with your left hand side hydrogen. So these two hydrogens get exchanged. My simple question is, what is happening to oxygen? Once I am passing a plane, where do the oxygen go? The guidelines say from whichever atom the plane passed from, that atom will not exchange its position. It will not exchange with any other atom, but within itself there is some change. What is that change? You try to imagine. When I am trying to pass a plane, it is bisecting the oxygen also. Just imagine that it is bisecting. All these are imaginary. Once it is bisecting the molecule, one half of the oxygen which is towards your right hand side, this half of the oxygen will exchange with the left half of the oxygen. But oxygen is remaining at its position, one half is being reflected into another half. The right half of the oxygen is reflected into the left half of the oxygen, but it is not exchanging with any other atom. Since there is a change within the oxygen, you generate an equivalent structure. So I am just trying to represent that particular plane which is passing only through oxygen. This I can call it as a sigma xz plane. This is the plane. Now if I number these hydrogens 1 and 2, 1 and 2 will exchange with one another. But what is happening to oxygen? It is intact, it is there, but within oxygen there is a shift that you have to understand. Suppose if I put with yellow, this is one half, that one half will be reflected to the other half, but still it is an oxygen, right? And what you generate is an equivalent structure. Always when there is a valid plane, by passing one plane we always generate an equivalent structure. If I try to pass another plane, that will generate an identical structure. You just take it as a guideline. One valid plane will generate equivalent structure, the second valid plane will always generate an identical structure. Or let me put it in a different way. Odd number of planes, odd number of valid planes will always generate an equivalent structure. Even number of valid planes will always generate identical structure. So I have generated an equivalent, you can generate an identical structure by passing one more plane. That is one plane. Now let me show another plane. This was the first one. Now just let me show a second plane. This is called as a molecular plane, because a plane that passes through every atom of a molecule, you can call it as a molecular plane. Now this is passing from every atom of the molecule. And once I am passing this plane, since it is passing through every atom of the molecule, all the atoms will not shift their position. So once I draw that plane, I only represent half of the plane. If you want, you can put a full plane, but I can show it this way. Once I draw this plane, you have to understand that this is a molecular plane, or this is a YZ plane. 1 and 2, since it is passing through every atom, oxygen will be at oxygen. 1 is at 1, 2 is at 2. So some students think that after operating a plane, there is absolutely no change, I am getting an identical structure, but it is not so. Just now I told you a guideline. Any odd number of plane or a single plane will always generate an equivalent structure. Even number of planes or two planes will generate identical structure. So we have done only one plane, we have done only one reflection. Therefore it has to generate equivalent structure. Without the shift of hydrogen, how can I call it as equivalent? Means now we have to imagine that one half is reflected into another half. This is a YZ plane. Once I pass a YZ plane, front half and back half are reflected into one another. I am showing it with this. This is pink colored, which is towards you, one half. Away is yellow colored. Imagine that this is a molecule. I am trying to pass a plane. Once I pass a plane, every atom is in its position, but this half will reflect towards you and this pink will reflect away from you. It is not a rotation, just I am showing it. So these halves, they get reflected into one another. Definitely there is some change. So this will generate equivalent structure. To identify that, what we can do is, let me take a plus. Imagine plus means that half which is towards you, a front half. Back half, let it be a minus. So once I am operating a YZ plane, front half will move away, back half will come towards you. This is not a charge, this is just a reference for your understanding. Plus is a front half, minus is a back half, and plus and minus are getting exchanged. So that would definitely generate an equivalent structure. Try to operate one more plane, one more YZ plane, that will generate an identical structure. So that is how we have to understand this plane. If you don't put such a reference for a beginner of symmetry, that would confuse you. Because it is passing from every atom and every atom is in its position, you say that it is identical structure, but it is not. It is an equivalent structure because front and back halves are getting exchanged with one another. That is with respect to water molecule. Now in one of the videos I said any plane which is parallel or any plane which is along the principal axis must be called as a vertical plane. So when I choose a water molecule, this is the principal axis, and any plane which is parallel to it or along with it must be called as a vertical plane. Therefore this sigma xz, I am calling it as a vertical plane. Next, this is also a plane which is parallel to the principal axis. Let me pass it this way or this way, it is just one and the same. Okay. Since this is also parallel to the principal axis, we can call both planes as vertical planes. This is also a vertical plane. In water molecule there are only two planes, and those two planes are called as vertical planes. Let's come to BCl3 now. In BCl3 there is a C3 rotational axis passing from the boron, and there are three C2s. When I rotate by 180, it is giving an equivalent structure. 1, 2 and 3. 3 C2s. C3 is the principal axis because it is higher fold. 3 C2s are perpendicular to C3 and C2s are the secondary or the auxiliary rotational axis. So with respect to that principal axis, I am trying to pass the planes. Suppose if I try to pass this plane, which is called as a molecular plane. If you are confused with half a plane, you can draw it full. This is called as a molecular plane because it is passing from every atom of a molecule. Molecular plane is not a different classification. That molecular plane could be a vertical plane or it could be a horizontal plane, but it is just a plane which passes from every atom of a molecule. Now once I am passing this, every atom will be in its position, but within an atom there will be a shift. So the front half will reflect with the back half. It is still chlorine 1. Chlorine 2, front and back halves will be reflected. Boron, front and back half will be reflected. Same is with the chlorine 3rd. So this is one plane. I am representing the principal axis for you because with respect to this reference we have to label this plane. Next plane, it is passing through a chlorine and a boron, central atom boron. if I put 1, 2 and 3, this is passing through boron and chlorine 1, therefore 2 and 3 get exchanged, that would produce an equivalent structure, and this is one plane. Now let me pass a second plane. This is passing from chlorine 3 and a boron, 1 and 2 get exchanged. In this case 2 and 3 get exchanged. I am also passing a third plane where 1 and 3 get exchanged, 2 and boron will be intact. So these are the three different planes that are possible. Now I am trying to represent it. If this is the BCl3 molecule, this is a molecular plane where front half will be reflected into back half, will generate an equivalent structure. Next, this is one plane which is passing from chlorine 1 and boron. This is another plane which is passing from chlorine 3 and a boron, and a third plane which is passing from chlorine 2 and a boron. You can check, one half will be reflected into another half. So one plane, two plane, three plane and a fourth plane. How do I differentiate them? We have to differentiate with respect to the principal axis. C3 is the principal axis and the principal axis is pointing towards you. This is a plane which is perpendicular to the principal axis, therefore I have to call it as a sigma h. Sigma h is the molecular plane in the case of BCl3. This is your principal axis. This is a plane which is parallel to it. This is your principal axis, a plane parallel to it. This is a plane parallel to the principal axis. Plane parallel to the principal axis. Plane parallel to the principal axis. So all these three planes are parallel to the principal axis, therefore I am calling them as vertical planes. Let's come to conclusion. Water molecule has two vertical planes. BCl3 has one horizontal plane and three vertical planes. Now coming to the ethylene, this is the principal axis and the remaining are the subsidiary axes. So let's try to pass the planes. This is one plane, XY plane. This is a XZ plane, and third one is a YZ plane, which is a molecular plane. Right, the third one is a YZ plane. Which atoms get shifted to generate equivalent structures? I am writing only the equivalent. Later on you can draw the identical structures. Above half and below half will be reflected when I pass a sigma xy. So 1 will be reflected into 2 and 3 will be reflected into 4. In the next case, right and left halves will be reflected. Rotations I have represented in another video, you can just check them. 1 with 4 and 2 with 3. So that will generate an equivalent structure. In the third case, it is passing through the atoms, therefore every atom will be in its position, but within the atom there is a shift. Front half and the back half will get reflected. So the front half of the hydrogen 1 will be reflected into back half of the hydrogen 1. They get exchanged. They do not exchange with any other hydrogen, but within each atom there is a exchange. So these are the three different planes that ethylene has. Apart from this, if you try to generate any other plane, you will not get it. You will not succeed in that. You can try it if you want. This is the principal axis. For group theory, principal axis considered will be different. This is for symmetry considerations. This is a principal axis and this plane is parallel to it. This is a principal axis, this plane is perpendicular to it. Principal axis parallel to it. Okay, if this is the principal axis, parallel to it. If this is the principal axis, perpendicular to it. And if this is the principal axis, parallel to it. Since this is parallel, I call it as a sigma b. Perpendicular, I call it as a sigma h. Parallel, I call it as a sigma b. You just look at here. Molecular plane is a horizontal plane. In this case, the molecular plane is a vertical plane. So don't try to relate molecular plane with always horizontal, or don't say that molecular plane will always be vertical. Molecular plane is that plane that passes from every atom of a molecule. Don't relate it directly to sigma h or sigma v. Concluding, for ethylene, ethylene has two vertical planes and one horizontal plane. Altogether there are three planes in ethylene. One sigma h and two vertical planes. For BCl3, altogether there are four planes. 3 sigma v and 1 sigma h. And for water molecule, there are two planes. Both of them are vertical planes. Whenever a molecule is given to identify the planes present in it, the first thing as a student that we have to do is to identify the principal axis, and with respect to that principal axis we have to differentiate whether the given plane is a vertical plane or a horizontal plane. To identify dihedral plane, I have done a separate video that you can check what exactly is a dihedral plane and what is the guideline to identify a dihedral plane. I have given a easiest guideline to identify the dihedral planes. Okay, thank you.